In 2025, small modular reactors, or SMRs, finally moved beyond conference slides and into real deployment. China now operates the world's first commercial Gen 4 plant, the HDRPM at Sherdao Bay, while the ACP 100 Linglong 1 on Hainan completed cold testing. It is preparing for hot tests and initial fuel loading, on track to become the first fully licensed PWRSMR of its class. In the Western world, the flagship is GE Hitachi's BWRX 300. Ontario Power Generation is building the first North American commercial 4-unit SMR park at Darlington, and the U.S. Tennessee Valley Authority is advancing the same design for the Clinch River site. The U.S. Department of Energy announced up to $800 million in support for two major SMR programs. Up to $400 million is allocated for TVA to accelerate deployment of the BWRX 300 at Clinch River. Another $400 million is for Holtec International to install two SMR 300 units at the Palisades site in Michigan, where a previously shut 805 megawatt reactor is being restarted. This strategy is simple and pragmatic. Reuse existing nuclear sites, infrastructure, and workforce to avoid first-of-a-kind delays and cost overruns. This marks the most decisive federal commitment to SMRs in U.S. history. The UK selected Rolls-Royce SMR as the winner of its national small reactor competition. The design, a 470 megawatt factory-built PWR module with a 60-year lifetime, is now in the final stages of regulatory review. London plans to deploy the first units in the early 2030s, aiming for up to 1.5 gigawatts in cumulative capacity. For the UK, this is not only a climate strategy, but an industrial one, reviving precision engineering, building an export product, and reducing dependence on imported natural gas. China's HDRPM at Sherdao Bay is regarded as the world's first commercial generation 4 nuclear plant. Two high-temperature helium-cooled modules power a single 210 megawatt turbine, a testbed for future hydrogen, industrial heat, and synthetic fuel clusters. Russia continues expanding its RITM 200 family, compact 50 to 60 megawatts PWR modules used on nuclear icebreakers and now adapted for the first land-based SMR in Yakutia. They are also adapting them for next-generation floating nuclear plants. The floating plant has already delivered over 1 billion kilowatt-hours over 5 years, remaining the world's only commercially operating floating SMR asset. One of the most symbolic developments of 2025 is big tech entering nuclear energy. Amazon and X-Energy announced the Cascade Advanced Energy Facility in Washington state, planning up to 12, 100 high-temperature reactors. Each unit will provide 80 megawatts, totaling up to 960 megawatts, dedicated to powering AWS data centers and AI clusters. Meanwhile, the first 100 is under construction at the Dow Chemical Complex in Texas to supply industrial steam and power. The signal is unmistakable. Data centers, AI workloads, and hyperscale computing are becoming a standalone demand driver for SMR technology. Big tech is ready to co-invest directly into project companies. Most SMRs will not enter commercial operation until the early to mid-2030s, creating a strategic niche for balancing assets. SMRs do not solve grid congestion or peak load volatility. To integrate them with hyperscale data centers, developers require modular thermal management systems, water treatment, and BESS and solar cluster integration. This is the natural integration interface with IMPC and EnergeticX as a systems architect. In a world where the DOE allocates $800 million to SMRs and big tech signs multi-billion-dollar nuclear energy deals, EnergeticX and IMPC can position themselves as the balancing and flexibility layer. They provide real-world AI applications for load forecasting, thermal cycle optimization, anomaly detection, and grid integration intelligence. This is the future of energy, where ambition meets reality.